Hey, Hammy here, back with another video on the last half of Chapter 4 on cellular respiration. Okay, the way that we take the sugars that we just learned about in photosynthesis and now use those sugars to power the cell, release energy for the cell. Okay, cellular respiration is the breaking down of glucose and releasing energy in slow steps so that it all doesn't just whoosh, get released as heat, but we try to capture that as much of that energy as we can in the form of ATP, which we learned in previous videos is the energy currency of the cell has just the right amount of energy for the cell. The equation for cellular respiration is obviously we're going to start with glucose, C6H12O6. Okay. It's going to be oxidized. We need 6 oxygen molecules. Okay, and then our arrow. And to keep it balanced, we're going to release 6 CO2s as a waste product, 6 H2Os, and energy in the form of ATP. So glucose is going to be broken down into carbon dioxide and water and released as energy. Okay, it's broken up into 3 different stages. Okay, stage 1 over here, which is happening in the cytoplasm, stage 1 is glycolysis. Stage 2, the products will then be moved into the mitochondrion, which we'll learn about in the next video. And step 2 will be the Krebs cycle. And the final stage is to take all the high energy electrons and make them kind of get the energy out of the electrons and turn them into ATP. In a process, here it's labeled oxidative phosphorylation, very similar to photosynthesis in the previous videos. The electron, it's going to be called the electron transport chain. Or the ETC. Okay, sometimes called the electron transport system, or ETS as well. Okay, in this video we just want to cover the first stage, glycolysis. If you split the word and kind of look at the roots of the word, glyco is going to refer to sugar or glucose. Lysis means splitting. It's going to happen in the cytoplasm of the cell, and it's going to split our glucose, our C6H12O6. Okay, so up here's our glucose, is going to get split. So you take 6 carbons, split it in half, you're going to get 2 3-carbon molecules, which we will get a bunch of electrons and energy out of. We're going to end up with pyruvates, or sometimes you'll hear pyruvic acid. So pyruvic acid or pyruvates, we're referring to the same thing. Now, in order to get glycolysis started, glycolysis, to get that split to happen, notice up here we have to put in 2 ATPs. So we have to add a little energy, and then we'll get a lot more energy out. Like sometimes they say, in order to make money, you got to spend some money. So our cells need to spend 2 ATP, but in the end, you'll notice that they get 1, 2, 3, 4 ATP out. Okay, so they'll end up with 4 ATP, which if you put 2 in and get 4 out, you get a net gain of 2. Okay, so you're still 2 to the good. You're getting a little bit of energy out of the process. You're also going to get, as you're breaking apart that molecule, as you break bonds, it's going to release electrons. Okay, those electrons are going to be captured in an electron carrier, NAD+, okay, which is going to form right here. NAD+ is going to catch those electrons and leave as NADH. Okay, these will later be taken to the electron transport chain where they will be used to make more ATP. And then you're going to end up with our 2 pyruvates down here at the end. Okay, so this is kind of the end here of the first step, just the splitting of sugar into 2 3-carbon molecules. This happens in the cytoplasm of the cell, and it happens in eukaryotic cells as well as in bacterial cells. It's kind of common, okay, throughout the cellular kingdom in harvesting the initial energy out of glucose. Okay. In the next video, we'll look at what happens with these pyruvates. Okay, where do they go next, and what is the mitochondria, or the powerhouse of the cell?